Hello, and welcome. Today, we're putting on our detective hats and going digital. We are diving deep into how investigators track down criminals who operate entirely online, where the crime scene isn't a place, it's the network itself.
So, here's the big question, right? A crime goes down online. There are no fingerprints, no physical witnesses. Where do you even start? Well, the thing is, the digital world might seem invisible, but it's absolutely packed with clues. Every single action leaves a trace, and today, we're going to follow that trail.
All right, let's step into our crime scene, the internet. But you have to understand, this isn't like a physical space. This crime scene is built on a very specific set of rules and protocols. So to find the evidence, we first have to understand the language that the internet speaks.
And at the absolute heart of it all is something called TCP/IP. You can just think of it as the internet's universal language, the grammar that every single device uses to talk to every other device online. It's the engine that makes the entire global network go, from sending data to making sure it actually gets where it's supposed to.
You know, a really great way to picture this is to think of a digital postal service. Just like a letter has an address, gets sorted, and finally delivered, TCP/IP breaks down our data into these little pieces and makes sure each one gets to the right destination. The IP part, that's like the address on the envelope. And the TCP part, that's kind of like registered mail, confirming it was delivered. Now, the way the internet works is totally different from, say, an old-school phone call. A phone call uses what's called a circuit-switched network. It creates a dedicated, unbroken line just for you. The internet, it uses packet switching. It basically chops your data, your email, a picture, whatever, into tiny little packets, sends them out individually, and then puts them all back together on the other end. It's way more efficient, and it's what allows millions of us to be online at the same time.
So, with all these tiny packets flying around everywhere, how does anything know where to go? And more importantly for our investigation, how do we know where they came from? This brings us to the first and maybe the most critical clue in any online case.
See, every single device, your computer, your phone, that web server, it gets a unique number assigned to it called an IP address. And it's not just an address, it's a return address. For almost every digital investigation, this is the starting point. It's the first thread that detectives start to pull on.
An IP address is actually structured a lot like a phone number. One part of it identifies the general network the device is on. That's kind of like the area code. And the other part identifies the specific device, the host, within that network. That's like the local number. It's a really simple but powerful way to organize the entire internet.
Okay, so we have our first clue, the suspect's IP address. But that's just a number. How do we turn that number into a name, a location, and trace the exact path that the criminal's data traveled across the globe?
Well, first, we use something called the Domain Name System, or DNS. You can think of this as the internet's giant phone book. We humans, we remember names like Yale.edu, right? But computers, they only understand the numbers. DNS is the system that works behind the scenes, translating the names we type into the IP addresses that computers need to find each other.
But here's the next twist. When you send an email or visit a website, those data packets don't just take a direct flight. Nope, they take a road trip, hopping from one specialized computer to another. And these are called routers. So the question becomes, how can investigators possibly reconstruct that exact journey?
The best way to think about it really is like a road trip. Each router is like a big junction with a bunch of road signs. It looks at a packet's final destination, checks its own internal map, which is called a routing table, and decides which road to send it down next. It's this massive, real-time game of connect the dots happening across the entire planet.
And guess what? Investigators can actually trace this path using a tool called traceroute. This table here, this is a real example of data traveling from Baltimore to Yale University. You can see it doesn't go straight there. It hops through routers in DC, then Newark, then Boston before it finally arrives. And every single one of those hops is a potential place to find digital evidence.
So, what kind of evidence are investigators even looking for at each of these stops? Well, the journey itself creates this trail of digital fingerprints, and they get stored in all sorts of logs all across the network. So, welcome to the Digital Evidence Locker.
I love this quote from the computer security expert, Tsutomu Shimomura. He said this after he was famously hacked by Kevin Mitnick, and it just perfectly captures what digital evidence is like. Intruders try so hard to cover their tracks, but the very act of covering them up often creates even more evidence. It is incredibly difficult to be a true ghost on the network.
So investigators are looking for clues in a few key places. You've got authentication logs, which show who logged in and from what IP address. Then you have application logs, which show what they actually did once they were in. State tables show what connections are happening in real time. And then you have logs on network devices, like routers, that show the bigger picture of all the traffic flowing through. And this is exactly how a digital action gets tied to a real person. In the investigation of the serial killer Maury Travis, police traced an Expedia map found in a letter from the killer back to a single IP address. They went to the internet service provider, who checked their authentication log. And boom, right there, it showed that the user account MSN/Maury Travis was using that IP address at that exact time. That was the link.
Application logs give you that next layer of detail. This simplified log from a file server doesn't just show who logged in, it shows you exactly what they did. We can see plain as day that user 32, coming from that specific IP address, deleted a specific file at a specific time. It's a complete record of the crime itself.
And evidence isn't just about what happened in the past. It can be about what's happening right now. State tables show live connections, so if an intruder is using a program like VNC to remotely control a victim's computer, that live connection shows up clear as day, listing the intruder's IP address. Now this all seems pretty airtight, right? Which of course just leads to a big cat and mouse game.
I mean, this all sounds pretty damning for the bad guys. But what about the really sophisticated criminals? Surely they have ways to hide, to fake their identity, and send investigators on a wild goose chase, right?
Oh, they certainly try. The most common advanced technique is called IP spoofing. And this is basically the digital version of forging the return address on a letter. The attacker crafts their data packets to make them look like they're coming from a completely different and often trusted computer.
It's a pretty complex dance. First, the attacker knocks a legitimate trusted computer offline so it can't interfere. Then they send a connection request to their target, but they lie and say it's from that offline computer. The target replies, thinking it's talking to the trusted machine, but the attacker intercepts that reply, forges one final response, and suddenly they're in. They're controlling a connection that looks like it's coming from somewhere else entirely. But even this isn't a perfect disappearing act. Remember that journey the packet takes, hopping from router to router? Well, the spoofed packets still have to travel that physical path. And while the final computer might be fooled, the routers along the way aren't. By piecing together logs from multiple points on the network, investigators can often trace the data back to its true origin and unmask the spoofer.
Ultimately, you have to remember that the internet was designed to connect things, not to hide them. Its very architecture creates an almost unavoidable trail of evidence. So I'll leave you with this to think about. In a world where our lives are more and more digital, what does it mean for our privacy and our security when every single click we make could potentially be a clue?